In an enterprise campus network system, there are several security features that should be practiced to prevent unauthorized access. One of the best practiced security features is port security. At the building access layer, access can be controlled at the port level, using data link layer information. Some examples are filtering based on media access control addresses, and IEEE 802.1 export authentication. Based on this concept, our topic today is focused on how to filter and authenticate devices based on Layer 2 information, which is achieved by implementing port security. What is port security? How is it implemented in a campus network system?
By default, all interfaces will be turned on the Cisco switch every time the device is started. That means that unknown device or attacker could connect to your network and potentially compromise it. Furthermore, when a port is active on a switch, any user can plug into that port and access the network. Since many networks use Dynamic Host Configuration Protocol (DCHP) to assign user addresses, it becomes much easier for someone with physical access to a network port to plug in his own device, such as a laptop, into the port and become a user of the network. From there, a person could proceed to generate traffic or cause other problems within the network. A simple method that many administrators use to secure the network from unauthorized access is to implement a feature called port security. Port security helps secure the network by preventing unknown devices from forwarding packets. By using port security, a network administrator can associate specific MAC addresses with the switch interface, which can prevent an attacker to connect to a network. This way, you can restrict access to an interface so that only the authorized devices can use it. If an unauthorized device is connected, you can decide what action the switch will take. For example, discarding the traffic and shutting down the port. How to configure port security. Port security enables you to configure a port to only allow a given device or devices access to the switch port, and limits the number of valid MAC addresses allowed on a port. The important point is that port security is disabled by default and only configured on an access port. Port security can be implemented in three ways. The first method is static, when MAC addresses are manually secured on the switch port. The secured MAC addresses configured in this way are stored in the CAM or MAC table and are added to the running configuration. Furthermore, you may see this configuration at the next boot if you copy from Dramtonvrim. The second method is dynamic. With this method, MAC addresses are dynamically learned and stored only in the address table. Furthermore, MAC addresses secured in this way are not added to the running configuration and are removed when the switch restart. The last method is sticky. This method combines the features of the first two methods mentioned. This means that, with this approach, the MAC address can be learned dynamically or manually configured by the network administrator. What are the actions taken by switch when the unauthorized device is connected? If a port is configured as a secure port, and the maximum number of MAC addresses is reached, any further attempts to connect by unknown MAC addresses generate a security violation. The switch interface can be configured for one of three violation modes, specifying the action to be taken if a violation occurs. Shutdown violation mode. In this mode, a port security violation causes the interface to immediately become error disabled, and turns off the port LED. It increments the violation counter. When the secure port is in the error disabled state as a result of this action, it is re-enabled by entering the no shutdown command. The second violation mode is restrict. With restrict mode, when the number of secure MAC addresses allowed on the port limit is reached, packets with unknown source addresses are dropped until a sufficient number of secure MAC addresses are removed, or the number of maximum allowable addresses is increased. In this mode, there is a notification that a security breach has occurred. The last violation mode is protect. When it comes to protect violation mode points, when the number of secure MAC addresses allowed on the port reaches the limit, packets with unknown source addresses are dropped until a sufficient number of secure MAC addresses are removed, or the number of maximum allowable addresses is increased. However, there have been no notifications of security violations. Here are the steps to configure port security.
First, let's verify the default configurations for port security.
Here are the steps to configure port security. The first step is to enable port security. By default, anyone can plug into a port and access network services. To protect a port, you must first enable port security on the individual port.
Step number 2 is to specify the number of MAC addresses. Once you enable port security, you need to determine how many different devices have access to the ports, and how many addresses need to be secured. The default value is 1 address. Step number 3 is to enter MAC addresses to be secured. By default, the switches will learn the MAC addresses of the devices that are plugged into that port. If you want to control which devices can access the switch. Step number 4 is to specify the action to be taken by the port. When a violation occurs, the switch generally protects the port by dropping the traffic that comes from unauthorized MAC addresses. After configuring port security on a switch, check each interface to verify that the port security is set correctly, and check to ensure that the static MAC addresses have been configured correctly. For example, to display port security settings for the switch, or for the specified interface. Now, let's see how the switch reacts when a frame is sent from an unknown MAC address. To do that, add the bogus device to your topology, and connect it to the network, via a secured port. As you can see from this demo, it causes the interface to immediately become error disabled, and turns off the port LED. Because the ventilation mode of this port is shut down. It also increments the security violation count by 1. Furthermore, it requires manual intervention to reactivate a port that has been disabled as a result of this action.